Okay, so we're talking probability, and we're saying, what if we had compound events, meaning two events are happening at the same time? Let's say we're flipping a coin twice. So we flip the coin the first time, we flip the coin the second time. These are two different events, so they're considered compound events. Or let's say we're taking two names out of a hat. Those would be compound events because we're doing two different things. And so if we're trying to find the probability of these, the first thing we need to do is identify if they're independent or dependent. Now, independent means one event has nothing to do with the other. So if we're talking about the two coins, those would be independent because when I flip the first coin, it doesn't matter what I got that first time because then when I flip the second one, it doesn't remember what happened on the first flip and then change it or keep it the same. It has its own independent outcome. And so that would be independent. And so when you're finding the probability of an independent, it's going to be the probability of A and B happening is going to be the probability of A times the probability of B. Whenever you hear the word and in probability, you're going to be multiplying. So if I'm looking at the probability, if I flip the two coins, I get tails and then tails again. If I'm looking at that probability, I'm going to find the probability of tails times the probability of tails. And I don't have to worry about anything. I don't have to worry about things changing. I just say, well, what's the probability of getting tails? It's 1/2. And the probability of getting tails again, well, if I flip a coin and get tails, that's 1/2. Okay, and multiply across the top, multiply across the bottom, my probability of getting both tails is 1/4. Now, if we go to the dependent event, that's where we're talking about two names out of the hat. Okay, so when we're looking at two names out of a hat, we're keeping the names out. So I draw that first name. Now that name's out of there, and I draw another name, and the probability for that has changed. For example, let's say that there's 10 kids in a class. I want to know the probability that the first one's a girl and the second one's a girl. Okay, now let's just say that there are 6 girls and 4 boys. Okay? So dependent probability is going to be a little bit different because with dependent probability, we find the probability of the first thing just like we normally would. But the second probability is not going to be a normal probability because if I just said the probability of B, then I just go back to the original problem and I look at what's the probability of B happening. But the fact is I can't do that because A already happened. So my notation is this line, and this line means given, and then I'm going to write A down. And so what this means right here, this means that what's the probability of B given A is gone. A happened. Okay? So if I go back to my probability of getting 2 girls, I'm going to look at the probability of a girl times the probability of getting a girl given the other girl is gone. So the probability of a girl is 6 out of 10. Times, now the probability of getting a girl after a girl's been taken, well now there's only 5 girls left because one of the girls was gone, one of the names is gone, and then now there's only 9 names in the hat. Okay, so my probability has changed. I can do some canceling, and I have 1/3 as my answer.